Testing, testing, 1, 2, 3. 1, 2, 3. Okay, fantastic. It seems like my audio is working. Now, for now, give me another maybe 1 minute or so. Now, for those of you who are my students and you're watching this, before I begin, allow me to just quickly tell you how things are gonna work. So, of course, this series of videos is going to be a bit of it's basically going to be your recap, right? This is going to be your crash course, right? You are probably at the end of your secondary 3 year, and you've probably forgotten some things. So I am here to remind you of what is important so that we can jump into the magical and maybe slightly agonizing world of calculus next year. Alright? So, because of this online format, please make sure to make use of the technology available to you. You should be watching this not live, but rather as a replay. Therefore, that means you have the ability to watch at double speed, you have the ability to skip around, and as a result, I will recommend you do that, right? Chances are you did not forget everything that you have learned this year. So keep that in mind as we move along. Don't be afraid to skip around or play faster. It's not going to hurt my feelings because you're watching a replay. So don't worry about it. Alright, now without further ado, let us begin. I will first start by briefly talking about what you can expect from AMath in general. So, just as a reminder of how the syllabus is laid out, we will be studying AMath for 2 years, and of course, this is only for upper secondary students, right? So we have Sec 3 and Sec 4. Now, in Sec 3, we're going to be learning quite a few preliminaries. We'll be learning about algebra, the fundamentals of two-dimensional graphs, and afterwards we will do a bit more advanced trigonometry. So algebra itself, there's a few things we have to cover, right? I will be covering quadratics. I will be covering surds, in other words, square roots. I will be covering exponents and indices. Of course, we will also touch a little bit about polynomials. For example, if we have polynomial division, how do I split something into partial fractions so that it looks nicer, it looks smaller? Aside from that, we will also go on to do some slightly more exciting topics, such as the basics of binomial theorem, and we will follow up our discussion of the laws of indices with the introduction of something known as logarithms. Then afterwards, right, so this will be our algebra portion. Then afterwards, we have the graphing portion and the trigonometry portion. For the graphing portion, all we need to know is basic coordinate geometry. And we will also touch on a little bit about the linearization of functions that would typically not be that nice to work with. For example, your logarithmic expressions. Last but not least, for trigonometry, we will be learning about their graphs. We will be learning about the 4 quadrants as well as the principal angles, and we will use them to solve equations. Because that's ultimately still a lot of math at your age. Learn how to find x. Simple, easy, understand. Right? Now, as for secondary 4, what we'll be doing is we'll be doing calculus, which can very broadly be split up into differentiation and integration. The differentiation side, we are going to cover all of the algebra that we have learned, and we will use it to solve various real-life problems, such as finding the tangent line, finding the normal line, finding rates of change for objects that are growing, shrinking, etc. We will also go on to talk about maximum points, minimum points, stationary points, as well as increasing and decreasing functions. As for integration, we will learn how to find indefinite integrals, and then we will learn how to do something known as a definite integral in order to find the area between a graph and some other object, for example, the x-axis. Last but not least, we will move on to the realm of physics and do a little bit of kinematics. Approximately 3/4 of all my students over the past 3 years have all been physics students as well, so I expect kinematics to be a bit of a break. And last but not least, we have plane geometry, which frankly speaking is an afterthought, so we shall not care too much about that for now. Alright, so that will be our outline of the syllabus. So without further ado, allow me to begin today's content proper. Today, what I am interested in is I would like to talk about quadratic functions, and of course some basic situations where we will be using quadratic graphs as models of real life situations. So for now, I will begin by doing a very brief recap of some particular formulas that you should be aware of. First of all is, of course, I need you to be aware of how to work with opening up brackets that have a square on them. For example, if I give you 2 minus 3x entire thing square, I will need you to recognize that we will be using this particular formula. Like so. Hopefully this rings a bell. If not, then I will need you to review your Sec 2 content. Right? Now, aside from all of this, something else will be, of course, the difference of two squares, which has been written for you on the left. A square minus b squared equals to the sum times the difference. I don't have a lot to say over there. Aside from that, I will also need you to be aware of how to factorize quadratic expressions. Having said that, however, for this, please just use your calculator if you know how to. You will be allowed the use of a scientific calculator in the exams, so for particularly ugly numbers, there's really no reason for you to do it manually, especially when you keep in mind that you will be working on a time limit. Now, having said all of that, there will also be some notation for me to introduce, but since this is an online video, I shall simply scroll down for a moment and let you see what we have here. So you should pause the video now and look at this in your own time. Now let's move on. For now, I would like to first talk about the basics that we have learned in terms of solving quadratics from Sec 2, right? From 1 year ago. So your teacher would have taught you something known as the zero product property. In other words, as long as I have any multiplication, I can split it up into two separate pieces, assuming that the right hand side is already 0. As a simple example, if I have x times y equals to 0, then I can say that x is equal to 0 or that y equals to 0. And then we can work on from there. Of course, it's entirely possible for us to see slightly more complicated scenarios. In fact, you don't even need to have two objects. We can actually have more than two objects. For example, you might see something such as x multiplied by x squared plus 1 multiplied by x minus 2 multiplied by ln x equals to 0. Of course, if you're looking at this as a secondary 3 student, then you will be asking me, what is ln x? But it doesn't matter. For now, all we need to recognize is that you should observe all these little multiplications over here. And of course, notice that, hey, the right hand side is a 0, which means that I will be able to tear everything apart and simply say that each individual piece separated by the multiplication sign will be equal to 0. From here, then you can go on to find the answers to the math problem. And we are done. Moving on, we have also learned a particularly notorious formula. Everybody hates this formula, and personally, I don't understand it. Reason why is because it will be given to you in the examination, so don't worry so much. You know, you're thinking to yourself, oh, is it b squared plus 4ac, b squared minus 4ac? Relax. Relax, it's given. So for any quadratic equation that takes this particular shape, we can always use this magical and slightly ugly looking formula in order to find the value of x. There is, however, one important criteria, namely that we must always have the quadratic formula have this particular shape. It is always algebra square, algebra number equals to 0. The coefficients can be anything. It can be plus, can be minus, you can have fractions, you can have 0, right? Unless the 0 is on the x square, because then that would no longer be a quadratic because the x square will vanish. But you can have any kind of number you want. All we need to do is to force ourselves to adhere to this shape. Algebra square, algebra number equals 0. Once you have this shape, then you can simply plug in the formula accordingly, and one example is given for you over here. Alright, now without further ado, let us move on. The next thing I would like to talk about is the process of completing the square. Now, completing the square means that we are taking the same algebra that we saw from just now. Algebra square, algebra number. And we are going to compress it into this particular shape, right? So we have something that is extremely long, and we will put it all into a bracket with a square. Realistically, real life will never be so perfect, and you're going to have numbers on as the coefficient and a constant on the outside. Doesn't matter, the point is we need to have a bracket with a square on it. You will observe that the algebra is limited to only the bracket, correct? The x is only inside the bracket. Everything outside of the bracket will simply be a bunch of funny numbers. Now, in order for us to do completing the square, I believe most of you would have learned this in secondary 2 actually, but as a brief recap of what we will do, The important thing to know is that we must always start off, right? We must always start off with the same shape as the quadratic formula. In other words, I will still religiously stick to the shape of algebra square, algebra, number, equals to 0. Once I have this, then I can move on to the second step, which will be to create the bracketed portion. Having said that, however, there's actually quite a few details to how we create this bracket. So let's zoom into step 2 for a little while. Currently we have, in this particular example on the right, 2x squared minus 20x plus 98 equals to 0, right? So what we're going to do is, the first thing I want you to note is this particular number in front. The 2, the coefficient of x squared. In order for us to package all the algebra into a single bracket, right? In order for us to achieve this particular packaging, it means that we're going to need to group all the algebra together, right? In other words, these two need to be together. And you will notice that the algebra itself has a coefficient on the outside of the bracket, which naturally also means that this person over here does not need a coefficient. He can simply be x by himself. Because if there was a number, I would just drag it out of the bracket. Then I don't need to write two numbers. Therefore, what we will do as the first step is to actually look at the coefficient of x squared and then factorize that coefficient out from all of the algebra terms, strictly the algebra terms. In other words, we will expect to see something like this. Once you have this, the next thing we will do is we will recall the formula for a square attacking a bracket. This particular formula always has a 2ab. So if I want to have bracket, algebra, plus number, close bracket, square, we will need to create the wavy underline, the 2ab. So what we shall do in order to create this is we will look at 10x. This 10x will be the middle term. And if you think about it, if this 10x itself is already 2ab, then we can actually figure out all the details we need. If 10x equals to 2ab and a equals to x, clearly b equals to 5. As a result, what we will do, in effect, is to simply take the coefficient of the x term, which is this guy, and we will divide by 2 in order to counteract this guy over here. Right? So the objective is to go back to a compartmentalized bracket. If we are going backwards, then instead of adding a 2, we will undo the 2 by dividing by 2. Consequently, we should expect to see 5. Once we are here, then we can move on towards the end. What we will do now is we will create the bracket like this. Do take note that the plus minus will carry over. The number in front, which was 2, will also carry over. At this point, however, you might notice that there's a very serious problem, which is that this person over here will be x squared minus 10x plus 5 squared. Which is weird because over on top, we only had x squared minus 10x. In other words, there's an extra 5 squared that should not be there. Right? An imposter has snuck into the algebra formulation we have right now. And the fact that we're using the equal sign means that it has to be equal, right? Everything has to be the same. So we cannot take in imposters. We're going to need to kill them off. In order to do that, what we shall do is, I will need you to look at the number you got from dividing by 2, in this case 5. This 5 will always produce an imposter that has a square on top. So we will minus him away. Having said that, this 5 comes from the algebra. And we factorized out the 2 from the algebra as well. In other words, the 2 in front must attack everybody that comes from the algebra, including the 5 square. So the imposter itself will need to be put in square brackets. And then from here, we can add back the 98. And from here, we will be done. Once you have this, the last step will simply be to simplify everything. And you should have 2x minus 5 square minus 50 plus 98 equals to 0. Once you are at this step, right, where the imposter has been eliminated and you simplify everything, then we can take this nicer looking expression and simplify. And from here, you can go on to do whatever it is you want to do. For example, if you want to find the value of x, you can make the bracket the subject and undo the square by slapping a square root on both sides. Don't forget to add the plus minus sign, and don't forget to check for a math error. If you have the square root of a negative number, it will be undefined, and then you will have no more math problem to deal with. Alright, now the next thing I would like to talk about is quadratic graphs. Since this is also a topic that many of us have learned in Sec 2, I will not spend much time on this, or at least on this particular page. The main thing I want you to be careful about is this section over here, where we have the graph of a completed square. Earlier, we have learned how to do completing the square, and now, one important tactic is that we can use completing the square in order to immediately deduce a few details about the quadratic graph. For example, I can immediately find the turning point, and of course, just by looking at the number in front of the bracket, I can tell if it will be a concave graph or a convex graph, an N shape or a U shape. If I have the shape and I have the maximum or minimum point, the turning point in general, then this will allow me to immediately draw the graph, and then we can find the rest of the details by using our standard algebra techniques from Sec 2, which will not be discussed in this video. Now, having said that, I would like to go through a few examples of graph drawing. So let us take a look over here. Now, of course, again, let me just re-emphasize, this is a video, right? You're watching the replay of a stream, so feel free to pause the video if you want to look at the examples. But for me, in the interest of time, I shall move on straight away. So over here, we have quite a few graph drawing exercises, and let us see what we can do about them. So for the first one, we have y equals to x squared plus 2x plus 1. What we are going to do is, we can actually simply use our secondary tool tactics and have this written as x plus 1 entire thing squared. You can open the brackets up and reach back to the original math problem as an exercise, but I will not do that over here. Once you have this shape, then based on what we learned on the previous page, we can tell that it will be a U shape with a turning point at -1, 0. So what we shall do is go on to draw this graph. Make sure to label the x and y axis. Okay, and whenever you draw the graph, it is always a good habit to, number one, label all the turning points. Number two, label all axial intercepts, meaning to say the positions where I slice the x-axis or the y-axis. If you do not recall how to find the axial intercepts, do remember that you can always substitute in 0 for the other algebra. For example, over here I cut y-axis at 1 because I can substitute in x equals to 0. X equals to 0 at the y-axis after all. Last but not least, another good habit for you to cultivate is to write down the name of whoever you are drawing. Be polite to the math. Alright? This is especially important because you're going to have situations in the exam where you might have to draw multiple people on the same picture. Right? You're going to have multiple people in your classroom and you don't want to call everybody, hey, ah boy, ah girl. Please refer to them by their names if possible. Whether you want to use the name of the original math problem or if you simply want to use your own version, right? For example, the completed square form. Regardless of which one you choose, it is okay. The important thing is to make sure that you have named everyone in order to avoid confusion. Now, the next two problems are particularly simple, if I'm being honest, because you would have seen this in Sec 2 already. We simply have two brackets, and when you have two brackets, you can use what we said earlier, the zero-sum property, in order to quickly get a graph for yourself. In this case, of course, this is not drawn to scale, pardon the lack of accuracy. In this case, we will simply cut the x-axis at -5 and +3. In order to find the turning point, I will go in between, and this will give me x equals to -1. From here, we will get y equals to -16. Last but not least, don't forget to label the y-intercept over here, which will be -15. You can either substitute in x equals to 0, or you can open up the brackets and take the constant term. Either way is fine. Now for the third problem, the method will be entirely the same, so I shall not even bother explaining. I will draw in the graph so that when you use these questions as an exercise, you will have the answers on hand. Especially for those of you who have joined my class in the second year, so you might not have went through all of this yet. Alright, so this is what we will have. The next few problems are a little more interesting. We see that there are some completed squares over here, right? You see the bracket, you see the square, you know something's up. So for those of you who haven't memorized what we learned on the previous page, please make sure to go refer to that again so that you can do these questions very quickly. You don't want to waste time in the exam if at all possible. The next two problems are also similar. All we see now is that there are extra numbers. These extra numbers are really not that big of a deal. They will inform your maximum point and your y-intercept. But ultimately, the method is the same. Number 1, find the shape. Number 2, complete the square. Number 3, find the turning point. In this case, we should have, let's see, 1, 2. And number 4, find the axial intercepts. In this case, we have a bit of a funny situation because your quadratic graph is actually going to be floating above the x-axis, right? We will talk more about floating graphs later on. Now for this next one, we will start to see some uglier numbers. This applies to all math in general, but please don't forget that in the actual exam circumstances, non-exact answers, for example square roots, should be left to 3 significant figures. So we will go on to use 3 significant figures in all the numbers here as well. Like so. Now for the last 3 problems, they are essentially the same in terms of the method, so I shall not spend any time going through them. please treat the understanding of these as a self-exercise. Now, in the previous question with ugly numbers, what I did was to do 3 significant figures. At this point in time, allow me to introduce another option, which is to leave everything in exact form. In other words, if there's a square root, screw it, leave the square root there. If there's a logarithm, screw it, leave the logarithm there. If there's a pi, screw it, write it as pi. Do not write 3.141592653589793238646. Not worth the effort. This is also a valid strategy, but I must warn you that doing things in exact form naturally means that your work will be messier as a result. For those of you who can handle it and avoid careless mistakes, this is a good thing, or rather, exact form is a good thing because it means you don't need to press the calculator. You will have a faster time. Unfortunately, for most of you, you will probably be careless all over the place. So you might want to reconsider whether it is worth it to be lazy and avoid pressing the calculator and run the risk of getting careless mistakes all over your work. And this completes our drawing exercise. Again, if you need to review anything, please pause the video by yourself. The next thing I would like to talk about is to use completing the square yet again in order for us to prove that a particular quadratic is always positive, always negative, never positive, never negative, so on and so forth. As the easiest possible and most trivial example, let us consider the algebra x squared. We know that you can square basically any number, strictly speaking, any real number. You can square basically any number and the result will always be non-negative. In other words, I will be greater than or equal to 0. So I can have anything square and it will be greater than or equal to 0. And therefore, if I have anything square plus a random object, and that object, of course, right, is a positive number, then that means I will necessarily be positive. This will be the strategy that we will be working with, and an example is given for you in question 1 on this very page. The next thing I will do is to go through a few exercises that are given over here. So let's look at question 2. Question 2 tells us to show that 2x squared minus 5x plus 4 is greater than 0 for all real values of x. So what we will do is, let us immediately complete the square. Step 1 is to take out the coefficient of the x squared term. And when we take out, we only take out from the algebra, so the plus 4 stays outside. Second step is to take the number, the coefficient of the x itself, and divide by 2. In other words, we should have x minus 5 over 4. Once you have that, put a square over the whole thing. Make sure to kill off the imposter. Make sure to attack everybody that came from the algebra with the coefficient 2. And don't forget to write back the 4, please. That will be embarrassing. Once you are here, then you can go on to simplify the result. Right, so once you have completed a square, all we need to do now is to point out that this quadratic portion over here, a bracket square, will necessarily be non-negative, in other words, greater than or equal to 0. However, the plus 7 over 8 is still around, which means that I will be greater than or equal to 7 over 8. And very commonsensically, 7 over 8 is greater than 0, which is what we wanted to prove in the first place, and we are done. By the way, in these videos, I will be using the tombstone to represent QED. Please don't do that in your exams. For you guys, you are students, so you don't get to do what the teachers get to do. Please write over there shown or proven, depending on what the question is asking for. Thanks. Now once you have this, then the second problem is simple. They want you to state the line of symmetry of the graph. Now in this case, the graph will be y equals to 2x squared minus 5x plus 4, which we have already discovered is actually simply this particular completed square. Now over here it is obvious that the turning point will be 5 over 4, comma, 7 over 8. And we know that the turning point is the position at which the U shape or N shape of the parabola is symmetrical, which means that we will simply say that the line of symmetry is the vertical line passing through this particular turning point. So the line of symmetry must be the line with equation x equals to 5 over 4, and we are done. Okay, now bear with me a little bit more. We are almost done. Once we are through with this portion, the last thing we'll look at is some stories, right? And then these stories will have quadratic functions inside them. Okay, so over here we have another exercise over here where it tells us to part 1 tells us to complete the square, part 2 asks us for the minimum value, in other words the turning point, and then afterwards we have part 3 and part 4, which are talking about the graph. So I will leave this as an exercise for you to do. I want you to think a little bit about part 4. They say that it's always positive, which means that you should expect the y coordinates to all be positive. Ask yourself, what does that mean about a U-shaped graph? If they're all positive, will they be all on top or all below? Then you can use that to answer the question. Now the last thing we need to talk about is the idea of using quadratics in order to solve real life problems. So I have 3 questions over here. One over here, one over there, and the last one over here. Now in order to ensure that you are familiar with how to play with quadratics, I want you to be confident whenever you see the square, right? I will be going through all of these. I will be going a little bit quickly, so please pause the video or slow it down or undo your 1.5 times speed at this point in time. Okay, so right now, what we will do is look at question 1. Question 1 tells us that we have someone who is basically up to some mischief, right? They are currently at the top of some tower, and then they throw a stone upwards and it falls down, falls down, falls down, falls down. And this is the ground on the floor. They then go on to tell us that there is a formula for the height of the stone that was thrown based on the time taken. Which means that based on my funny little drawing here, you could actually simply try something like this. Right? We will take the tower as the y-axis, or in this case, the h-axis. And we will take the time taken to be the independent variable, the x-axis. The graph with this particular n shape will then simply be h equals to 9 plus 4t minus 4t squared. Now the first problem is a bit of a funny one. They want us to find the height of the tower that this girl is on. So you're probably thinking to yourself, wait, that doesn't make sense. The question was talking about a stone. Why are they asking for the height? So in order for us to estimate the height, I want you to remember that t, in this case, stands for time. So what happens when t equals to 0? Now you might be surprised to hear this, but if t equals to 0, that means that time is 0, correct? No time has passed. So this is like pausing a video right at the beginning. The video has not started playing yet. The stone has not even left the girl's hand yet. The stone is still on the tower, which means that the height of the stone can be used as an estimate for the height of the tower itself. In other words, I will take t equals to 0, substitute it into this formula for the height, h, and we will immediately get h equals to 9 meters, and we are done. The second problem wants us to do completing the square. I will leave the working as an exercise for you to do. Your final answer will end up being this. The third part will be quite straightforward. They would like you to state the maximum height reached by the stone. In other words, find the maximum point. Since you have already completed the square, it is obvious that the maximum point will be half comma 10, and therefore the maximum height is 10 meters. Now part 4 is a little more interesting. They ask us to find the time until which some boy who is standing on the ground floor catches the stone. The problem is he doesn't catch the stone when it reaches the bottom of the floor, because if you want to catch the stone when it touches the floor, you're going to need to crouch down like a frog. Kero kero kwa. So if you don't want to be a frog, then you're going to reach out your arms normally, you're going to catch it as it falls towards you, and chances are your height is going to be maybe somewhere around the range of 1 meter, which is the number that has been given to us by this math problem. So right now, you can imagine we have this little gap of 1 meter. The boy who is standing over here on the floor, diagram not drawn to scale, obviously, will catch the ball at this particular position. And what this means is that at this point in time, the height h, which is equal to our completed square, this height will be equal to the height where the stone was caught, which is 1 meter. Right, so I will set my answer from part 2 to be equal to 1. From here, you should go on to have t minus half square equals to 9 over 4. And from here, we have t minus half to be equal to plus minus 3 over 2. Of course, since time itself is a non-negative concept, right? It's greater than or equal to 0. We will not accept negative 3 over 2. We will use positive 3 over 2, and therefore get time equals to 2 seconds. And for the last part, part 5, sketch a suitable graph in context. all I need you to be careful of is the words in context. In context means that you must follow the story, and therefore we have three important things to take note of. Number one, it is not x and y, it is t and h. Number two, you will not have negative time. So your graph will be similar to the orange portion of the diagram on the left. You will start from 0, you will not start from negative. Number three, remember that the stone gets caught at 1 meter. It does not fall to the ground. Therefore, having said all that, we can now replace our funny little drawing on the left over here with a proper graph. Your graph will look something like this. Very obviously, this graph is not drawn to scale, but as long as these numbers are there, then you will be safe. Please don't forget to write down the name of the person you are working with, just like how you write down your name on every single worksheet that you do. Alright? So in this case, if I had accidentally drawn anything on the negative time portion, or if I drew the stone hitting the ground, or worse, if I drew the stone crawling underground, right, just digging its way underneath, let's dig up. If that is the case, then you will absolutely get penalized. Make sure to follow the story. Now, if there are no issues, let us move on to the next exercise. The next exercise tells us that we have two people playing golf. These two boys play golf, and a formula that tells us the height of the ball has been given to us. Please be reminded that this capital letter or small letter or whatever with a bracket over here is not multiplication. This is something known as function notation. In other words, L is the name of the algebra. The bracket x just means that the algebra takes in x and returns 7x minus x squared over 5. In other words, the bracket is like your stomach. You eat something and then you vomit something else out. For example, I could eat up stick figure, and I will get 7 times stick figure minus stick figure square divided by 5. It does not mean L multiplied by stick figure. So, having said that, let us take a look over here at what we have. The question tells us, first of all, that when x equals to 0, both of the functions give us 0 for some reason. So we will simply tell them that the reason it is 0 is when we have L0, P0, it means that we are at x equals to 0. And if you are at x, wow, tongue twister. And if you are at x equals to 0, then that means the ball has not yet been hit. And if it is not yet hit, then obviously it is just sitting on the ground. It is just sitting there peacefully. So if it's sitting on the ground, of course the height is going to be 0, because there is no height to speak of. I'm just on the ground. Now for the subsequent portion, part 2 focuses on Prince. Now this guy over here, he has hit his ball in accordance with the formula 24 over 5x minus 3 over 5 x squared. And we want to sketch a graph of his golf ball. So we shall have the following situation. The graph drawing by this point in time will hopefully be very simple for all of you, right? Again, please go back to the page about drawing graphs for completed square and for expanded form if you are still unfamiliar. Do take note that in this question, you do not need to label the algebra exactly. You can simply say that the algebra is Px, because P is the name of the algebra. Right? From here, then we have part B. Part B asks us to deduce the time during which the golf ball is airborne. Having said that, however, if you look at the diagram that we have drawn, you will see that the golf ball is essentially starting from the left. It gets hit into the air, and then it lands on the floor on the right. Wouldn't that simply mean that the x-axis, which is telling us time, will tell us the time in which the ball is in the air? Therefore, we will simply say that 8 seconds have passed. Last but not least, for part C, they want us to find the maximum height. Again, if you look at the drawing that you yourself have drawn in part A, you will see that the maximum height is clearly 48 over 5 meters, and we are done. Thereafterwards, they tell us a little story. They tell us that these two boys, when they're playing golf, there was some strong winds that were blowing. And if the ball was higher than 3 meters, it gets completely blown off course, right? Maybe it gets blown into a sand bunker. Maybe it gets blown into Malaysia. Maybe it gets blown into someone else's swimming pool. I don't know. Right? So, in this case, I think it is very clear that Prince has screwed up, because his maximum height is 48 over 5 meters. That's 9.6 meters. That's way too high. It has probably been blown all the way to the other side of the world, and then back, and then to the other side of the world again. So congratulations, he missed. So it is very clear that for part 3, which is to explain who was more successful, it is very clear that the answer is going to be Lucas. All we need to do is to prove it. Prove that Lx is lesser than 3. So in order to do that, if you recall, whenever we have all these inequalities, one strategy will simply be to use completing the square. Okay, let me talk to people on YouTube for a moment. Please feel free to skip, like, I don't know, 30 seconds ahead. Okay, I don't know if that was 30 seconds, but I wasn't counting. It's alright. Okay, so over here, they would like us to prove that the algebra Lx is lesser than 3. So we will simply say that Lx is equal to 7x minus x squared over 5. This person over here is very clearly equals to negative 1 over 5. X squared minus 7x. You will recall this from approximately 15-20 minutes earlier, and what we did was to simply start by factorizing out the coefficient of the x squared term. What I said earlier was to factorize out the coefficient from all algebraic terms, but in this case we're lucky. There's no constant at all. We have x squared, full stop. That's it. There's nothing else. Consequently, we will simply factorize out the negative 1 over 5, and we will carry on with the remaining steps by dividing the coefficient of x by 2, slapping the bracket and the square on top, subtracting away the imposter is sus. From here, then we will take a square bracket in order to make sure the negative 1 over 5 attacks everybody that came from the algebra. Of course, in this case, there is nobody that did not come from the algebra, so we have a pretty simple scenario over here. Once you have this, it simplifies into 49 over 20 minus 1 over 5, x minus 7 over 2 squared. Since the bracketed portion is greater than or equal to 0, it clearly means that the bracketed portion with the coefficient negative 1 over 5 will be lesser than or equal to 0. And this implies that 49 over 20 minus 1 over 5, x minus 7 over 2 square, this person it's the same as what we wrote on the left, except we plus the 49 over 20. And therefore, we will say lesser than or equal to, and instead of 0, we will also plus 49 over 20 to get 49 over 20. Now, conveniently, 49 over 20 works out to approximately 2.45. No, sorry, exactly 2.45. And 2.45 is very obviously less than 3. And therefore, we have gotten the algebra Lx less than 3, which is what we wanted to prove. QED. And we will end the lesson. Wow, we wish. And we will end the exercise by saying that Lx is less than 3, but Px is greater than 3. So only Lucas's ball, his golf ball was the one that was not blown away. So the question asks, which of the two boys had a successful golf ball hit? We will tell them only Lucas was successful. Prince was tryharding too much. His ball went up over 9 meters and it got blown all the way to the other side of the world. Right? So if you have simple explanations like that, don't panic. Simply answer to the requirements of the question. The question has told us the veto factor, which is if the ball's height exceeds 3 meters, then that's it. Game over. You should kill yourself. No. Right? So if you have 3 meters, that's it. Game over. If you are less than 3 meters, then you will be safe. And then, of course, we will go on to say that the one who was safe, Lucas, will be the one who had a successful ball hit. Now for this third problem that we have over here, I will leave this problem to you as an exercise, and I will invite you to take a look at the screen as I bring up something else entirely. Now I have 2 extra exercises over here. One very simple one about completing the square, and one very difficult one where I throw a coconut at someone's head. So let us very briefly go through the completed square problem first. So they tell us that we would like to prove someone over here is always positive for real values. So this will be very similar to the question we just did. It suffices to use completing the square in order to prove the positive behavior. Step 1, factorize out the coefficient of x squared from only the algebra. Step 2, take the coefficient of x, divide by 2, slap a square over the whole thing. Step 3, the imposter is sus. Step 4, everything that came from the algebra, put it in square brackets and let the coefficient of x squared attack the whole thing. Don't forget to write back the plus 13. From here, then we will go on to simplify what we have over here, right? When you are simplifying, don't be misled by the negative signs, right? The negative sign attacks the bracket, not the person inside the bracket. Therefore, it is perfectly fine to have a negative answer. If the negative sign was inside the bracket, then of course, we will be in trouble. But that is not the case over here. Anyway, once you simplify everything, you should get 12. Now over here, this is greater than or equal to 4 multiplied by 0 plus 12, which is equal to 12. And 12 itself is positive. And that is what we wanted to prove in the first place, QED. Right, again, the key technique is to recognize that this bracketed person over here, right, this bracketed person over here has a square. And when you attack yourself, when you multiply yourself, you're going to end up with greater than or equal to 0. So that will be our strategy. Right, so once we have this, we have the second part over there. Second part asks you to find x, relatively easy. They want the exact value, so you can either use the quadratic formula or you can use completing the square. In this case, they have forced our hand by insisting on completing the square, so let us proceed to do that. Let me take a swig of water first. Okay. So the completing the square process over here is pretty straightforward. We will have x squared. Why am I still in green? They want us to solve for the value of x. Do notice that they forgot the equal to 0. So please help me add that in. Right, so we have x squared plus 6x minus 11 equal to 0. And of course, x squared plus 6x minus 11 itself is also equal to x plus 3 square minus 3 square minus 11. Notice that we can skip the first step, right, where we factorize out the coefficient of x squared because, well, it's 1. So there's no point in factorizing out 1. Right? So once we are over here, we shall proceed to, of course, simplify everything. So bracket square minus 3 square minus 11, that will be minus 9 minus 11, that will be minus 20. And then this person will be equal to 0, which is what we said earlier, right? So I am dragging this guy over here. From here, it's clear that we have x plus 3 square equals to 20, which implies that x plus 3 will be equal to the square root of 20. When you take the square root, please don't forget to do plus minus. Consequently, we will solve the problem by simply moving the 3 over. In other words, we conclude that x is equal to negative 3 plus minus square root 20. And we are done. We will leave the square root as is because the question said exact form. We do not want to do any estimation. No rounding off, no significant figures, none of that weak stuff. We will leave things exactly as is. We will give perfection. For those of you who are so inclined, if you would like to write the cert over here as 2 root 5, be my guest, right? So in this case, we will simply have, oh, my bad. We will simply have the following. Right? So for those of you who want to show off and simplify, please go ahead. Depending on the math problem, you might have to simplify. Right, so let us move on to the final problem of the day. Right, finally the class is ending, right? Of course, I don't think any of you are particularly fed up because you'll be watching this at home and as a crash course. So I hope you took my advice and you're not playing this at 1 time speed. Unless you're working along with me, in which case thanks, I feel a little less lonely now. But please don't do it at the time I'm doing it. It's 2:20 a.m. over here. Now, our final problem of the day is another grandmother story. So I am throwing a coconut towards the sea, and the coconut height is given by some funny little algebra. However, the algebra is not given to us. What they do is they tell us that, when I draw the graph of this algebra, it starts from 0, 1, it has a maximum point of 5, 5. And the first part of the question wants you to find the algebra by yourself. Second part of the question asks you to find the algebra when x equals to 0 and asks you to explain what the answer tells you, what is so important about the answer. Part 3 then asks us, right, I have a friend who is currently swimming underwater, and when I throw the coconut and the coconut reaches sea level, it bonks her on the head, right, just kaboosh. And then part 4 tells us, oh, she's angry, she throws the coconut back, and you want to find the algebra again, just like part 1. And part 5 is the explanation question. Will she be able to get revenge on me for bonking her on the head? So let's start with part 1 first. This will actually be very exciting. All our previous problems have given the algebra to us on a silver platter. But in this case, we see that we have to create the algebra by ourselves based on the given information. So in order for us to work this out, you have two options. You can either start from the expanded form, algebra square, algebra, number, or you can start from the completed square shape. In this case, let's try to be cheeky and let us start from the completed square. We will let the algebra for height hx be equal to random number, bracket, x minus random number, bracket, square, plus random number. A, B, and C are random real numbers. Of course, we should specify that A cannot be 0. Alright? Now once we have set the rules of the game, then we can go on to say that since the maximum point, right? Since the maximum point is 5, 5, if you recall what we learned earlier about drawing graphs from the completed square, it is very obvious that B will be equal to 5 and C will be equal to 5. More specifically, this B over here, right, actually maps to the x coordinate. It is the magic number that turns the bracket into 0. And this C over there will simply be the outsider who is uninfluenced by the affairs of the bracket. He will always be there. That's why even if anything weird happens, we'll still have this particular 5 over here. Now at this point you might be thinking to yourself, wait a minute, but what if it is a U-shaped graph? By using this method, aren't we finding the turning point? And the turning point is the minimum point of a U-shaped graph. But this is where I point to you the fact that A, small letter a, is still an unknown value. If a is lesser than 0, you will have an n-shaped graph, and then the turning point will be the maximum instead. In fact, I believe it is quite clear that in this case a will actually be negative, because think about it for a moment. I'm throwing a coconut into the air. What goes up must come down. So of course we're going to end up with this particular falling shape, this particular N shape. So now that we have, oh, I forgot to switch back to black. Now that we have found B and C, we have hx to be equal to a x minus 5 square plus 5. And once you are at this stage, the rest of the problem should be quite straightforward, because the graph starts from 0, 1. In other words, I can just substitute 0, 1 into what we have over here. So 1 will be equal to a 0 minus 5 square plus 5, which is equal to 5 minus, 5 plus 25a, like so. And from here, a will be equal to negative 4 over 25. Once you're done with all of this, then we can conclude the math problem by saying that hx will be equal to negative 4 over 25, x minus 5 square plus 5, which then opens up to negative 4 over 25x square plus 8 over 5x plus 1. And we are done. This is what we wanted to show. So for convenience sake, allow me to write down the completed square. Right now we have negative 4 over 25 x minus 5 whole thing square plus 5. Alright, this will be the completed square of the math function that we were supposed to get in part 1. Now that we're done with that, then we can move on to part 2. Part 2 asks us to find h0 and to explain what this result represents. Now normally when they use the English word find, that would be pressing your calculator to find the exact value. In this case, however, we don't even have to do that. The word find can be taken literally because they have already given us the point 0, 1. So clearly, we have h0 equals to 1. And they want us to explain what this result represents. So there's any number of explanations you can give over here, any number of suggestions. What I like to imagine is if I'm standing on the beach and I want to throw a coconut towards the sea, what happens when the time is 0? That means that the coconut is still in my hands, correct? So I can simply tell them that the coconut was held in my hand at 1 meter of height. Of course, if you want to give any other alternate answers, that's completely fine. For example, you could say that my hand, right, is resting 1 meter above the ground height. That's completely fine. Or 1 meter above sea level. That's also completely fine. The point is to give a reasonable answer. Try and take the algebra, the pure mathematics, and bring it into something that at least makes reasonable sense in real life. We don't expect perfect answers over here. We just want to see whether your brain is working. Hopefully your brain is working. Okay, so now over here we have the next portion of the problem. The coconut is thrown, it reaches sea level, and then bonk, I hit someone on the head, right? So what we are going to do is we need to find the exact horizontal distance traveled by the coconut once it bonks my friend on the head. So you can imagine right now that I have this graph over here with time on the horizontal and height on the vertical, right? I start at 1 meters, I throw the coconut, bonk, I hit Eka, who is currently over here. And I would like to find the time taken, which will be given over here. So you will notice that this will simply be the distance from the starting position 0 to the x-intercept on the right, which is, of course, obtained by setting algebra equal to 0. So we shall do exactly that. So for part 3, we currently have hx equals to, and then we will have negative blah 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 blah, which is equal to 0 when I hit my friend. From here, what we shall do is the standard algebra techniques that we have learned. Find the value of x by moving this positive 5 over, turn him into negative 5. Once you have this negative 5, we will also need to move this coefficient over. So we will need to divide by negative 4 over 25. So this should give you a result of 125 over 4. From here, then x will simply be 5 plus minus the square root of 125 over 4. Of course, once you have this particular formulation, don't forget to throw away the answer that is useless, right? So over here, we have these particular values of x. And we will now say, since x is time, it is non-negative, we will only accept 5 plus the square root of 125 over 4. At this point in time, if you're watching this video, hopefully you would have learned a bit about surds already. So similar to earlier, let us briefly simplify this result. And then we are done. So this will tell us the horizontal distance traveled by the coconut that I threw. I throw the coconut, it sails forward by 5 plus 5 square root 5 divided by 2 meters, and then bonk, it hits my friend on the head. So once we have this part done, right, let us just briefly draw the result somewhere. Let's see. So this is me. Okay, and then I will take the coconut and throw it all the way like this. Right? I'm starting from the beach. I will throw the coconut, and afterwards it flies forward. It hits my friend in the head. And of course, one important thing you will want to note down right now is to keep in mind this distance that we have found, which is 5 plus 5 root 5 over 2. Okay? So over here we have this particular distance. The coconut flies forward in an N shape, and then it bonks my friend over here on the head. Extremely painful, I can imagine. But for those of you who know who this girl is, I think you will be comforted by the fact that she's already dead. So don't worry, it's not like there'll be any injuries or anything weird like that. So Eka is currently on the right over there, and she just got bonked by the coconut, so she's feeling a little angry, a little angsty. She takes the coconut, she tosses it back towards me. That will be part 4. And similar to part 1, we see that we have another problem, being that, hey, the algebra isn't given to us. They told us that the coconut has some specific values, right? They tell us, it starts from the origin, there's a maximum point at 5 over 2, and then now we need to start all over from scratch. So let's go ahead and do that. A little bit depressing, but don't worry, everything will come together in part 5. So now she's trying to get revenge. For those of you who are viewing this live stream right now and already know the math, at this point in time, I think you probably would have figured out the ending to this story. It's a tragedy, very sad. So part 4, we will do the same strategy as before, right? By deliberately creating some unknowns and then working backwards to find the values. Now, in the previous part 1, what I did was to use the completed square shape. So in order to exercise our minds a little bit, let us try and do the expanded form this time. We will let a car y be equal to py squared plus qy plus r. P, q, and r are constant real numbers. P is not 0. Alright? Now in this case, we know that the graph, right, starts from capital letter O, the origin, which is written over here. Let's see. The graph starts from the origin O. So if it starts from O, then that will mean that E0 equals to 0, which is equal to P times 0 square plus Q times 0 plus R, which obviously will simply be equal to R. And if it's equal to R, then that just means that R equal to 0. So we are left with EY equals to PY squared plus QY, which conveniently can be factorized in this manner. Now once we are over here, then we can go on to work out what we should have for P and Q by using the maximum point. So what we will first do is we will substitute in the maximum point 5 comma 5 over 2, and this should give us a value of 5 over 2 equals to P times 5 plus Q whole thing times 5. In other words, we should expect to see 25P plus 5Q. Once we're done with that, the next thing that is important is to keep in mind that right now what we have is we're going to have this N shape, okay, and it's going to cut at 0 and at negative Q over P. Now why is it negative Q over P? Reason is because it will make this person equal to 0. Remember, the very first thing we learned in today's video is we can split multiplication when 0 is on the right hand side up into two separate pieces. And from here we can find y equals to negative Q over P. So let's use this value, y equals to negative Q over P. Now if y is equal to negative Q over P, then that means that the maximum point will be in between, right, over here. This is where the maximum point is. And because it is directly in between, it will simply be negative Q over 2P. So we will say that since 5 comma 5 over 2 is the maximum point, negative Q over 2P will be equal to 5, the x-coordinate. Right, so once you have gotten these two values out, the last thing we need to worry about is to actually find P and Q. So what we will do is we will actually do simultaneous equations. You see that we currently have 5 over 2 equals to 25P plus 5Q, and we have negative Q over 2P equals to 5. This gives us two pieces of information, which is perfect for finding two different unknowns. Right, so at this stage, for the actual simultaneous equation finding, right, I am not going to work it out. I would rather not waste everyone's time. I believe the answers, why am I still in a highlighter? I believe the answers should be P equals to negative 1 over 10, and then Q will be equal to, I think Q is just equal to 1 actually. Is it just equal to 1? I think it's equal to 1. Right, so once you have found your two different values, then we can put these two values of P and Q back into the original thing we said, which is Py squared plus Qy plus R. Now, even better is the fact that R is equal to 0. We already found that earlier. And therefore, we don't even need to care about it. We can simply say that a car y will be equal to negative 1 over 10 y squared plus y. Alternatively, if you want to make it look nice, you can factorize out 1 over 10y and change it into 10 plus, no, sorry, is it plus? No, minus y. If you want to do this, that's completely fine. Alright, so up to this point, that will tell us how to find the algebra for a car's portion. In other words, we currently have EY to be equal to 1 over 10 y bracket 10 minus y, like so. Now from here, then we are almost done. Let me erase a few things. Meanwhile, help me look at the last part of the question. The last part of the question is a simple one. We would simply like to see if Eka managed to get her revenge against me. Will the coconut bonk me after she chose it? Why or why not? Notice that they are asking you to explain yourself, right? It's not enough to simply guess and say, oh, it's not going to hit him. He's going to be safe. You need to briefly tell me why by using the numbers that are available based on what we have calculated so far. So in order to work this out, I invite you to look at our answer from part 4 again. Wait, let me change the thickness on this. Yeah, make it extra thick. Okay, I invite you to look at the algebra we have over here again. If you imagine the graph, correct? If you imagine the graph, what we expect is to start from 0, shoot out to 10. Like so. So you can imagine that the girl is over here and that I am somewhere on the right hand side. And the problem is, in order for the coconut to hit me, one key difficulty that must be managed is that the coconut must reach me in the first place. This is where we have a problem, because the distance of the girl's coconut is 10 meters. But the distance of my coconut over here, if you calculate it out, is actually 10.590 meters to 5 significant figures. In other words, what this means is that I am actually very, very far away from her, right? The coconut went this way, it's true, but I'm actually standing all the way to the side. I'm too far away. Regardless of how high the coconut is, regardless of how heavy the coconut is, blah blah blah, the fact is that it only traveled 10 meters forward, but I am 10.6 meters in front of the girl. So if you travel 10 meters forward, it's not enough. You're not going to be able to bonk me on the head. So the last thing we need to do is to explain that. From part 3, Junwen and Eka are 5 plus 5 root 5 over 2 meters apart. But Eka's coconut only travels 10 meters forward, so I, Junwen, will not be bonked. And we are done. So all we need to do is to point out this difference in the horizontal distance of the coconut and use that to conclude that this girl, her arm wasn't strong enough, right? The coconut didn't fly far enough to even reach me, right? If it flew over me, there's still a chance, right? Like maybe I could jump or something, I don't know. If it flew over me, she just needs to use less strength. But if she's throwing at full power and it's only 10 meters, then it's impossible for her to get revenge. Although maybe revenge isn't the right word because I didn't bonk her deliberately, but the point is that she is unable to get revenge on me. And that will conclude this question. Right, so this will be our final exercise for today. This was a bit of a long lesson in the end because I wanted to really make sure that we are confident with quadratics, because the next topic after this chapter is going to be simultaneous equations with quadratics, the quadratic discriminant, quadratic inequalities, and basically we're just going to see a lot of ax squared plus bx plus c. So I want you to be very confident with this. Alright, so up to this point, that will be all for today. If you have nothing else for me, I have nothing else for you. You are dismissed.